Hey everyone, today we are going to solve the Daily LeetCode challenge of 26th March 2024 and the problem statement is first missing positive. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array nums such that it contains both positive and negative integers, correct? And what we have to do is we have to find out the first missing positive integer. Correct. Now, what is a positive integer? A positive integer is, let's say if we have x, then this x should be greater than 0. Correct. So an integer is positive when it's greater than 0. Fine. So let us understand this problem with a couple of examples. So these are the three examples. Let us first discuss the first example. So here we can see that we have a 0 and we don't consider a 0 as a positive integer. Correct. So let's ignore it. Now we have a 1, we have a 2. Okay, so what are we missing? We are not missing any integer in between this 1, 2. So what will be the first missing positive integer? It would be 3, correct? Similarly, in example 2, we can see that we have a -1. So -1 is not a positive integer. So let's ignore it as of now. Okay, so we have a 1. After 1, we should have a 2. But do we have a 2? We don't have a 2. So the first missing positive integer would be 2. Now, in the third example, we have 4, 5, 6. But what is the smallest positive integer? The smallest positive integer is 1, correct? Do we have 1 in this case? So we don't have a 1. So what would be the answer? The answer would be 1, correct? Because we have to find the first missing positive integer, right? Now let's see if we can find out a pattern over here. So in the first example, we can see that what is the length of this num? The length of this num is 1, 2, 3, correct? So it means that this num should contain all the integers starting from 1 to 3, correct? Because it has a length of 3, right? And in order for it to contain all the positive integer, it should have all the number from 1 to 3, like it should have 1, it should have 2, it should have 3. So let's see, do we have this 1 in nums? So we have this 1 in nums. Do we have this 2 in nums? We have this 2 in nums. Do we have this 3 in nums? So we don't have this 3 in nums, right? And this is our answer, that this is the number which is missing. Correct. Similarly, in the second example, what is the length of nums? The length of nums is 4. So what does it mean? It should contain positive integers starting from 1 to 4. Correct. That is, it should contain 1, it should contain 2, it should contain 3 and 4. So let's see, does it has 1? So we can see that it has 1. Does it has 2? So we can clearly see that this nums doesn't has a 2. Correct. So what is the first missing positive number? The first missing positive number is this 2. Correct. Now, similarly, in the third example, what is the length of nums? The length of nums is 3. It means that it should contain integers from the range of 1 to 3. Correct. That is, it should contain 1, 2, and 3. So, does it contains 1s? We can clearly see that nums doesn't contain 1. So, what is the first missing positive number? It's nothing but 1. Correct. So, what did we understood? We understood that if we have been given any array, right? So, which all elements should it contain? It should contain elements from the range of 1 to n. Correct. Where what is this n? It should contain 1 to n, where this n is what? N is the length, correct? The n is the length of the array. So it should contain integers from 1 to n. Now, if it missed any of the integer in this range, like here we saw that it's missing this 3, right? That is, its length is 3, so it should have 1, 2, and 3. It's having 1, it's having 2, but it's missing this 3. So we are returning this 3. Similarly, here the range was from 1 to 4, and we were missing out this 2, correct? And similarly, here the range was from 1 to 3. So it means it should contain 1, 2, and 3. And it's not containing 1. So 1 is the first positive number, correct? So it's missing this one. So that's why we return this one. So let us understand how we can solve this problem. So now that we have understood that if we have an array of length n, right, then it should have integers from the range of 1 to n. So what are we going to do is we are going to create a vector which would be of size n plus 1. Why it would be of size n plus 1? Because we are having values from 1 to n, including this n, correct? And what we will do is, it would be a Boolean vector and we will set all the values initially as false, representing that these values are not present in nums, okay? And let's say that the vector name is present, okay, is present. Now what we will do is, we will iterate over this nums and whenever we'll get a positive number, that is whenever we'll get a number which is greater than 0, then what we will do? We will simply turn the false value present at that index to true. Because what do we know? We know that the elements in this num should be from the range of 1 to n, right? That's why we created an array of size n plus 1, correct? And what we'll do, whenever we'll get a value, we will turn it to true. But what do we need to take care of? We need to take care of that number should be positive. And second thing that we should take care of is that it should be less than n, right? Because there could be a possibility that we can get an integer greater than n, because in this case, what should be the range? The range should be from 1 to 10, correct? But here in nums, we can clearly see that we are getting a number which is greater than this 10, right? Which is out of this range. So before setting the value to true, we also need to check that that value should be firstly greater than 0. That is, it should be a positive number and it should be less than equal to n, correct? Then only we are going to mark its presence in this vector, correct? So let's quickly do a dry run for this test case. Okay. So initially what we will do, we will start iterating in this nums. So we can see that our current element is 5. So what we'll do is, we will turn the Boolean value to true at the 5th index. Why? We are indicating that this value 5 is present in this nums, correct? Now we'll move forward. So we have got a 2. Now what do? We'll turn this false to true because this 2 is present in nums. Now we'll move forward. Now we have got a 1. So what we'll do? We'll turn this false to true. We'll move forward. We have got a 4. So we will turn this false to true, indicating that this value 4 exists in nums, correct? Now we'll move forward. We have got a 0. So we'll check that is this value greater than 0. So 0 is not greater than 0, right? So it means that it's not a positive number. So we are not going to consider it. So we'll simply move forward. So we have got a -9. So we will check, is this -9 greater than 0? So this -9 is not greater than 0, correct? So it means it's not a positive number. That is, it's not a valid number and it's not in the range of 1 to 10, correct? So we are going to simply ignore it. So we'll move forward. Now we have got a 10. Now we'll check, is this 10 greater than 0? So 10 is greater than 0 and is this 10 less than equal to n? What is n in this case? N is 10, correct? So is this 10 less than equal to 10? So 10 is less than equal to 10, correct? So what are we going to do? We are going to turn the value present at this 10 to true, correct? And we'll move forward. So we have got a 3. Now we'll check, is this 3 greater than 0? So 3 is greater than 0. And is this 3 less than equal to n? It's less than equal to n. So we will turn its false value to true. And we'll move forward. Now we have got a 14. Now we'll check, is this 14 greater than 0? So it's greater than 0, correct? Now, is this 14 less than equal to 10? So this 14 is not less than equal to 10. So it means that it's not in the range of 1 to 10. So we'll simply ignore it. Now we are at this 7. So what we'll do, we will turn the false value to true at this 7, because we can clearly see that this 7 is greater than 0 and this 7 is less than equal to 10 as well, correct? Now we will again move forward. Now we can clearly see that we have processed all the elements of nums, correct? So now what we will do? So what was our first step? Our first step was to iterate over nums, and if we get that the current value is greater than 0 and it's less than equal to n, correct? Then what we have to do? We have to set the is present. We have to set is present of x as true, correct? Indicating that this x is present in our nums. Fine. After that, what we'll do in the second step? In the second step, we will simply iterate over this is present, correct? Starting from the 1th index to the 10th index, right? So what we will do? Iterate over is present from 1 to 10, right? And what is this 10? This 10 is n, right? And why are we starting from 1 and not from 0? Because we don't consider 0 as a positive number, right? That's why we are starting from this 1. And what we will do, if we get that any of the value is false, if is present of x is false, then what does it mean? It means that it's the number which is not present in our nums, right? So what does it mean? It means that it's the first missing positive number. So what are we going to do? We are simply going to return that x, correct? So let's do the second step over here. So currently we are present at the first index. So we can see that the value present at the first index is true, indicating that this 1 is present in nums. And we can see that 1 is over here. So we'll move forward. So the value present at 2 is also true, and we can clearly see that 2 is present in nums. So we will move forward. The value present at 3 is also true. So we can see that 3 is also present in nums. So we'll move forward. Now the value present at 4 is also true, and we can see that 4 is present in nums. So we'll move forward. And the value present at 5 is also true, and we can see that 5 is over here. So we'll move forward. Now we can see that the value present at the 6th index is false, correct? What does it mean? It means that this value 6 is not present in nums. Now let's see. So do we have a 6 over this nums? So we can clearly see that we don't have 6 in this nums, right? So what does it mean? It means that this 6 is the first missing positive number, correct? And what we did, we simply returned this 6. Fine. So this is the approach which we will be going to follow. Okay. Now let us consider a case. Say for example, if instead of this 0, we would have a 6. So this false would be true, correct? Indicating that this 6 is present. Okay. Now let's say instead of this 9, if our nums would be containing this 8, then the value for this 8 would have also been true, correct? And now let's say that instead of this 14, we were having 9. So this false would also have been true, indicating that we have a 9 in nums, correct? So if we have a nums like this, in which we have all the value in the range of 1 to n, we can see we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, 8, 9, 10, correct? We have all the values from 1 to 10. So what is the missing number? If we don't get that any of the value is false, it means that we will return n plus 1. And what is n plus 1? N is 10. So n plus 1 would be 11. So 11 is the first missing positive number, right? So in a case when we don't get an answer from this vector, that is when all the value present in this vector is true, in that case we'll simply return n plus 1. That is, in n plus 1 is the first missing positive number, because we don't got any missing number in the range of 1 and 1 to n, right? So it's pretty sure that if there is no missing number from 1 to n, then n plus 1 is the number which is missing, right? Now, what would be the time complexity for this approach? So what we are doing first is, we are firstly iterating over the nums in order to set this is present to true for all the integers which is present, right? So it means that we are going to iterate over all the n elements. So this first operation is going to cost us a time complexity of order of n, correct? And secondly, what we are doing is, we are iterating over the is present array, correct? That is this array, in order to check that which is the missing number. And what is the length of this is present array? The length of this is present array is n plus 1, correct? Here, the length of nums was 10, and here the length of is present array is 11. So it means that what we will be doing, and since we are iterating from 1 to 10, so it means that we are iterating from 1 to 10, we can clearly see. So it means that we are going to iterate over all the n elements. So it means that the second operation will also cost us order of n time complexity. So order of n plus order of n will give us order of 2n, which is nothing but order of n only, correct? And what would be the space complexity? The space complexity would be order of n. Why? It's because we are creating this is present array from our end, right? And it is going to cost us a space complexity of order of n. Now the question is, are we going to use this solution in order to solve this problem? So the answer is no. Now let's see why. So we can see that in the problem statement, it's clearly mentioned that it should use only constant extra space, correct? So let's see a solution that has a constant extra space. Now we understood one thing, that we have to solve this problem in a constant space. So let's see how we can do it. Now, one thing is for sure, that all the elements in this num should be in the range of 1 to n, where n is the length of the array. Okay. Now, what we will do in this approach is, firstly, we will remove unnecessary values. Now, what all values are unnecessary? Now, what do I mean by unnecessary values? All the values which are either less than equal to 0 or which are greater than n. So, these are the unnecessary values. Why? If a number is either less than or equal to n, then what does it mean? It means it's not a positive integer, right? And what are we care about? We only care about finding the first missing positive integer. So if a number is not even positive, so why should we bother about it, right? So we will simply remove it, or we'll simply ignore it, correct? And we know that if we have a length of 10, like in this case, the length is 10, right? So if we have a length of 10, then there should be elements from 1 to 10, right? So if we will get any element which is greater than this 10, what we will do, we'll simply remove it, because it's an unnecessary number, right? So we are going to remove it, because if this num should contain only numbers from 1 to 10, right? So it means that if it is missing a value, so it should be something in between this 1 to 10 only. And if all the elements from this 1 to 10 is present, then what does it mean? It means that 11 is the first number which is missing, correct? And we saw the same in the previous example as well, right? So it means that we don't need any value which is greater than this n, correct? So we are going to remove them. Now let's see how are we going to remove them. So we are going to turn all these values to 1. Now why are we turning it to only 1? Why only to 1 and why not to some another number? So I'll discuss it pretty soon, okay? So what we will get after transforming this array, so we have 5. So 5 is greater than 0 and it's less than n. So it means we are not going to change this 5. So 5 will remain as it is. After that, we have a 2. So we can see that 2 is greater than 0 and it's less than equal to n, right? So it will remain as it is. Now we'll move forward. Now we have a 1. Now this 1 is greater than 0 and it's less than equal to 10. So 1 will remain as it is. We'll move forward. Now this 4 is also greater than 0 and less than equal to n. So this 4 will also remain as it is. Now we'll reach to this 0. Now we can see that this 0 is not greater than 0. So it means it's an unnecessary number. So what we will do, we will turn it to 1. So it means that we have this over here, correct? And while doing this step, while doing this, that is while removing the unnecessary values, we also have to do one more thing, is we have to keep track whether we have this 1 present in our nums or not. So let me say that I have a variable called is present 1. So it represents whether this 1 is present in our nums or not. And initially its value would be false. Okay, representing that 1 is not present. But we can see that here we found a 1 in nums, right? So the moment we'll find 1 in nums, what we'll do, we will turn its value to true, indicating that 1 is present in nums, correct? So since its value is true now, so what does it mean? It means that this 1 is present, correct? So where were we? We were at this 0. So since this 0 was unnecessary, we turn it to 1. Now what we'll do, we'll move forward. So we have got a -9. Now this -9 is not in the range of 1 to n, correct? It's not in the range of 1 to 10. So what we'll do, we will remove it by turning it to 1. Now we'll move forward. Now we have got a 10. So it's in the range of 1 to 10. So it will remain as it is. Now we'll move forward. We have got a 3. Now this 3 is also in the range. So it will remain as it is. Now we have got a 14. Now this 14 is not in the range of 1 to 10. So what we'll do, we will remove it by turning it to 1. Okay. Now we will reach to the 7. So 7 is also in the range of 1 to 10. So it will remain as it is. Okay. Now we are done with the first step, that is to remove all the unnecessary values. And by following this first step, we are also doing one thing, that is we are keeping track whether this 1 is present in nums or not. Correct. So what we have got that this 1 is present in this nums. Now, if this 1 would not have been present in this num, that is if this is present once would have been false after completing the first step, then what did it mean? It means that 1 was not present. So from there, we would have simply returned 1. But since we have got that 1 is present, so there is no need of returning 1 from there, right? Because 1 is present. So now we can see that all the values present in our new nums is from the range of 1 to 10, correct? We can see we have 1, 2, 3, 4, 5, 7, 10, correct? So all these numbers are in the range of 1 to 10, right? Now let's see what are we going to do. So currently we will iterate over this nums. So we are over here, that is we are at the element 5. So what we will do is we will turn the sign of the element present at the 5th index to negative. And why are we doing this? We are doing this to indicate that the element 5 exists in nums. Correct. Now what we will do is we will move forward. So what is the value present over here? The value present over here is 2. So what we will do is we will turn the element present at the 2nd index to negative, correct? So that is we'll set this one as -1. And why are we doing this? We are doing this so as to indicate the element 2 exists in nums, correct? Now we will move forward. So we are at this -1. Now an index of -1 doesn't exist, right? Because if we are going to access nums of -1, it's going to give us a runtime error. So what we will do? So at each steps we are going to check abs of nums of 1, correct? Because this nums of I is negative, right? Here we can clearly see that this 1 is negative. That is we are having -1, right? So we can't simply write nums of -1. So what are we going to do? We are only going to take its magnitude. That is, we are only going to take the value and we are not going to consider the sign, right? So we are only going to consider the absolute value. So what is the value over here? The value is 1. So what we'll do is we will turn the sign of the element present at this 1 index to negative. That is, we will set this as -2, indicating that the element 1 exists in nums, correct? Now we'll move forward. So the value we have currently is 4. So what we will do, we will set the element present at the 4th index to negative, indicating that the value 4 is present in nums. Okay. Now we'll move forward. So what we have got a 1. Okay. And we can clearly see that the element present at the 1th index is already negative. So since it's already negative, there is no need to turn it back to negative. Okay. So we'll simply move forward. Now we have again got a 1 and we can clearly see that the element present at the 1th index is already negative, right? So we can't set this as minus of -2 because if we would do like that, its sign will turn into positive and we don't want its sign to turn into positive, right? So what we'll do, since it's already negative, it means that we have already marked that the element 1 is present in num. So we'll simply move forward. Now what we will do, we have got a 10. Okay. So what we were doing till now, we were setting nums of, say for example, if we are at 6th index, right? So what we were doing, we were setting nums of 6 as negative, correct? So what is nums of 6 over here? Nums of 6 is 10. So what are we going to set? We are going to set nums of 10. So, but do we have nums of 10? We don't have the 10th index, right? So if we are going to access nums of 10, it's going to give us a runtime error. So for handling this case, what are we going to do is, if we have a value, so this value is what? This value is 10, right? So if the value is 10, what does it mean? That this value is equal to n. correct? Value is equals to n, because what is n? N is 10 only, right? The length of the array is 10. So whenever we get a value which is equal to the length, so in that case, what are we going to do? In that case, we are going to turn the value present at the 0th index to negative, correct? Indicating that the nth value exists. Because look, our range is from 1 to n, correct? So it is pretty obvious that we won't have the element 0 in our nums, right? And we don't even care whether it's present or not in nums, right? So it's for sure that the element present at the 0th index would never turn negative, because 0 will not be present in nums, right? Because we have already removed it. So what we are going to do is we are going to take advantage of that situation for this case. That is, whenever we'll get a value which is equal to this n, then what are we going to do? We are going to simply set the value present at the 0th index to negative. Correct? And what we'll do now, we'll simply move forward. Okay. Now we have got 3 over here. So what we will do, we will set the value present at the 3rd index to its negative, right? That is, we have a 4, so we'll set it to -4, indicating that the element 3 exists. Correct? Now what we'll do, we'll move forward. Now what we have got a 1. So what are we going to do? We are going to turn the element present at the 1th index to negative, indicating that this 1 is present in nums. But we can see that the element present over here in the 1th index is already negative. It means that we already have a 1 in nums, so we don't actually need to turn it to negative, right? So what we'll do is simply move forward. So what is the value now? The value is 7. So what we'll do, we'll turn the element present at the 7th index to negative. That is, we'll set this 3 to -3. Now we can clearly see that we are done with the second step. Fine. Now what we will do, once we are done with the second step, we'll simply iterate over this nums. And what are we going to do? We are going to check that which is the positive number. So is this a positive number? No, it's negative. Is this a positive number? No, it's negative. Is this a positive number? No, it's negative. Is this a positive number? No. Is this a positive number? No. This is also not positive. Now we'll see that this 10 is positive. Now this 10 is positive. What does it mean? It means that the element 6 doesn't exist. Why? It's because if this 6 was present somewhere in nums, right? Let's say if we have 6 over here. So if we had this 6, then what we have done? We would have set the element present at the 6th index to a negative element, correct? But since this element is not negative, since this element is positive, so what does it mean? It means that we didn't encounter 6 in our nums. That's why this value is positive, right? That's why we didn't turn the sign of this value. So it means that secondly, when we are iterating, the value which are having negative signs, so all its indices have been visited, right? That's why its sign have been turned to negative. But since we didn't had 6 in nums, so we didn't turn the sign of the element present at the 6th index to a negative, right? So we'll simply return this index from there, correct? So let's do a quick recap again. So what we did, first of all, we removed all the unnecessary values, right? That is, if we have a value which is less than equal to 0, that is if we have a 0 or if we have any negative number, then we don't need to worry about it. So what we are doing, we are simply removing it. And if we have a value greater than n, then we are removing it as well. And how are we removing? We are removing it by replacing it with 1. Now you may ask, why are we removing it with 1 and not with some other value like 10 or 12 or 100 or something? So we can have a test case in which the length of the array is only 1, right? And let's say the element present in the array is -1. Okay, so this -1 is an unnecessary value because it's a negative integer. So you will say, okay, let's remove it with 100. So what we'll get, if we'll transform the array, we'll get 100. Now what we were doing in the second step is we were iterating over this nums. And why we were iterating? While iterating, what we were doing, we were setting the value present at this index, right? That is, if we were at this 5, so what we were doing? We were setting the value present at the 5th index to negative. So what we'll get? We'll get 100. So what we will do? We'll set the value present at the 100 index to the negative, right? But do we have 100 index present in our array? The answer is no, right? So what is the smallest value which we can have? The smallest value which we can have is 1. We can't set all the value to 0. Why? Because 0 is an unnecessary value, right? So what is the smallest possible value that we can set it to? We can set it to only 1, right? That's the reason we are turning all the unnecessary values to 1. Okay. And while turning them to 1, we are also keeping track whether we have this 1 present in nums or not, right? Because what if we didn't keep track of whether 1 is present or not, and we have turned all the integer, all the unnecessary values to 1? Then in that case, whenever we'll get a 1, we'll turn the value at the 1th index to negative, right? So we will say that 1 is present even if 1 was not present. So that's the reason while removing the unnecessary values, we are also keeping track whether this 1 is present or not, correct? And if the 1 is not present, then it's the smallest positive value which is not present. So we'll simply return 1. But what if this 1 is present? So if this 1 is present, what are we going to do? We are going to iterate over nums, and we are going to set the, let's say we are currently at 5. So we are going to set the element present at the fixed index to negative, indicating that the value 5 exists in nums. And if we get a value which is equals to n, right? That is, here we can see that we got a 10 and 10 index doesn't exist. So in that case, what we'll do, we'll simply turn the sign of the 0th index to negative, correct? And lastly, we'll iterate over this nums, and we'll check that if any of the value is positive, so simply return its index, because if this value is positive, then that only means that the index, that is the 6, this value was not present in nums, correct? Now I hope it's clear to you all, so let's quickly code this. So firstly, what we'll do, let's find out the length of nums. So we'll say nums.size, and we'll store it in n. And we also need a Boolean variable. Let's call it as is present 1. So we are using it to check whether 1 is present in this nums or not. And what are we going to do? First of all, we are going to remove unnecessary values, correct? And what all values are unnecessary? So if we have a value, say x, which is less than equal to 0, or if we have a value x which is greater than this n, so it's unnecessary, right? Because it is out of the range of 1 to n, correct? So we are going to remove all the unnecessary values. And how are we going to remove them? We are going to remove it by turning it to 1. And by doing so, what we have to do, we also have to track if 1 is present. So let's do it. So we'll say for index equals to 0, index less than n, index plus plus. What are we going to do? If we have nums of index as 1, then we'll turn this is present 1 to true, indicating that we have got a 1, correct? Now, else if what we can have, else if this nums of index could be less than equal to 0, that is, it's a negative integer, or we can have that this nums of index is greater than n, then it means it's also out of the range of 1 to n, right? So what are we going to do? We are going to remove it. And how are we going to remove it? We are going to remove it by setting the value present at nums of index to 1. Correct? So we'll have a 1 over here. Now we are done with the first step. Now after the first step, what we have to check? We have to check if this is present 1 is still false, right? Then what does it mean? It means that 1 is not present in our nums. So 1 is the smallest positive number, right? So it means that 1 is only missing. So we'll simply return 1 from here. Okay. But what if this 1 was present in this num? So what are we going to do? In that case, we are going to go to the second step. And what we were doing in the second step? In the second step, we were iterating starting from index 0 to index n. Correct. And what we were doing, for that we have to check that if nums of index is equals to n. In that case, what we were doing? In that case, we were setting nums of 0 as minus of nums of 0, correct? But there could be a possibility that this nums of 0 had been already negative, and if we are going to set it again to negative, then what will happen? In that case, it will turn into positive, but we don't want that, right? So what we will do is, we will write this abs over here, correct? Now, if nums of index is any value other than this n, in that case, what we'll do? In that case, we'll simply set nums of index as minus of nums of index, correct? But there could be a possibility that this nums of index is already negative, right? So what are we going to do? We are going to take abs over here, and we are going to do the same thing for here as well, correct? So we are going to write abs over here, and we also have to write an abs over here, because we want the absolute value, right? Now, once we have turned the sign of the values which are present to negative, now what we have to do? We have to iterate over it in order to find the missing value, right? So we'll say for index equals to 1, index less than n, index plus plus, correct? So what we'll do? We'll say that if nums of index is greater than 0, then what does it mean? It means that this particular index was not encountered in nums. And since it is not present in nums, that's the only reason why the value present at that point was not turned into negative. So what are we going to do? We are simply going to return the index, correct? And now once we are done with this and we still don't have got a number which is 6. So in that case, what we have to do, we also have to check that if our nums of index, if that's greater than 0, then what does it mean? It means that the nth value is missing. So what are we going to do? We are going to return n. Because whenever we encountered n, what we were doing? We were turning the element present at the 0th index to negative, right? So if we get nums of 0 as positive, so it means n is positive, n is missing, correct? But if we see that n is also present in our nums, so what does it mean? It means that all the elements in the range of 1 to n is present, correct? Because if any element in the range of 1 to n was missing, then we would have got it from here, right? But if we didn't got it from here, then what does it mean? It means that all the elements in 1 to n are present. So we are simply going to return n plus 1th element, correct? One more thing, don't forget to write abs over here, correct? Because there could be a possibility that the value present at nums of index would have been turned to a negative number, right? So if we are going to check whether negative 10 is equal to 10, so it's going to give us a false, right? So don't forget to write abs over here as well. So let's now quickly submit it, and it got accepted. Now talking about the time complexity and space complexity. So if we have a total of n elements in nums, then the time complexity is order of n. Let's see why. So here we can see that what we are doing over here. Here we are iterating over the entire array nums in order to remove all the unnecessary values, right? So it means that we are going to iterate over all the n elements. So it's going to cost us a time complexity of order of n. Okay. Now here we can see that what we are doing over here. Over here, we are iterating over all the n elements in order to set the value. Say for example, if I get a value at any index, let's say if I'm at the 1th index and if I get a value as 2. So what I'll do is I'll set the value present at that 2th index to negative in order to indicate that this 2 is present in nums, right? And for how many times we are doing it? We are doing it n times because we are going to do it for all the n values present in nums, right? So it will cost us a time complexity of order of n. Fine. Now what we are doing over here? Over here, we are checking that if we have an element that has a positive sign or that is positive, so we are going to return it. So in the worst case, we can have like all the elements are negative. So in that case also, we are going to iterate over all the n elements, correct? So the time complexity for this would be order of n. So order of n plus order of n plus order of n will give us order of 3n. And since 3 is the constant, so we can simply ignore it. So we'll get a time complexity of order of n. And we are not using any extra space from our end. That's why the space complexity is order of 1. So that's all about today's daily LeetCode challenge. Thank you.